Now we are starting question number 6 of this topic, work, power, energy for AS level. Loads A and B of masses 1.2 kg and 2 kg respectively are attached to the ends of a light inextensible string which passes over a fixed smooth pulley. A is held at rest and B hangs freely with two straight parts of this string vertical. A is released and start to move upward. It does not reach the pulley in the subsequent motion. Part 1. Find the acceleration of A and the tension in the string. Part 2. Find for the first 1.5 meters of motions of A. Part A. A's gain potential energy. B. The work done by the A by the tension in the string. And C. A's gain in kinetic energy. Then B hits the floor 1.6 seconds after A is released. B comes to rest without rebounding at the string becomes slack. Find the time for the instant when the strings become slack until it becomes taut again. So this is the question 6 of that exercise. Since in this problem the two balls are there of masses 1.2 and 2 kg and they are hanging vertically downward. So let's say here is a pulley which is frictionless. This particle A of mass 1.2 kg and there is a other particle which is of mass 2 kg. They are hanging vertically. Pulley is frictionless. So they are connected with a string which have the tension T in that part. Weight of B is equal to 20 Newton and weight of A is equal to 12 Newton. Then they are asking find the tension and the acceleration in that particle there. Since B is 20 Newton and A is 12 Newton, so B will move downward and A will move upward. So we know that from the equation of motions, driving force minus the resistive force is equal to net force. For particle A, the driving force is T there, minus tension is, weight is there 12, and that is equal to 1.2 into A. For B particle, weight is verting downward, so weight minus tension is equal to 2A. Our weight is basically equal to 20 minus tension is equal to 2A, and let's say that is 2, and let's say that is equation number 1. Now we will solve these two equations together. That is tension minus 12 is equal to 1.2A and 20 minus tension is equal to 2A. We will subtract this and this cancel out. So 20 minus 12 is 8 and This 2 plus 1.2, that will become 3.2a, or a is equal to 8 over 3.2. So a value is equal to 2.5 meter per second square in this question there. This is the first part. Then they are asking find the tension in that string. So we can use any one of this equation, either one or two. So if we use the equation 2 there, 20 minus tension is equal to 2 into acceleration we have calculated as 2.5. So 20 minus t is equal to 5. Our tension is equal to 20 minus 5. Our tension is equal to 50 Newton is the answer for the tension of that string within this part of that calculation there. Now we will use the B part. Find the for the first 1.5 meters of A's motion. So this means A has moved 1.5 meter. Find A's gain in potential energy. So this particle A is moving for a height of 1.5 meter. So distance is equal to height, and that is equal to 1.5 meter. Then the gain in potential energy of particle A, which is equal to mgh. So mass of that, or in simple words, mass of A into G into H. So mass of A is given there 1.2, G there is 10, and height there is 1.5 meter. And this is equal to 18 joules. For the next part of the same question, the work done by the tension in that string. Work done by the tension of the string A there. Because tension in the string is T, and that thing is equal to 15 into height, which is 1.5. So that thing is equal to 7.5 joules. It is 22.5 joules. Then the next part, they are asking A's gain in kinetic energy. So when they ask about the gain in kinetic energy for the particle A, that we are going to calculate. But we know that kinetic energy of particle is half mv square. So we have going to calculate the value of v there, and then we can put in this and you can get the value of the gain in kinetic energy of that particle there. Since the particle is going to move 1.5 meter upward, so we can have this equation of motion there. 2as is equal to v square minus u square. We know the value of 2, we know the value of a, which is given there equal to 2.5, and the distance it has moved s, that is 1.5, is equal to v square minus 0 square. So v square is equal to 5 into 1.5, that is 7.5. Then the gain in potential energy of that particle A is equal to half mass of that one is 1.2, and v square is basically equal to 7.5. So this is 0.6, and this whole value is equal to 4.5 joules is the answer for this part of the kinetic energy of the particle A there. And then the last part of this B hits the floor 1.6 seconds after A is released. B comes to rest without rebounding and the strings become slack. Find the time for the instant when the strings becomes slack until it becomes taut again. So here is the pulley. B is going to hit the ground and it is 1.6 seconds it is going to take in that part. So A is going to move upward and then the strings will becoming slack and then it's going to be taut again. So we know that V is equal to U plus AT. So V is equal to U is A starting from 0. Acceleration of A is 2.5 and the time is there 1.6. So that thing is equal to 4 meter per second. So a particle will move from this to this part when the string is taut, and from this to this part when the string is becoming slack. So we know for this particle A, this final velocity will become the initial velocity, and that is also 4 meters per second. When it reaches the highest point, its velocity would be equal to 0. And because it is not under the influence of any tension force there, so it is moving under gravity. So we will going to use A is equal to G for that part. So from this portion P to the Q, when it is slack, so we know this calculation that V is equal to U plus GT. V is 0, U is 4, G is minus 10 into T. So time T will be equal to 0.4 seconds from P to Q there. And Coming back towards that, it will take the same time. So it is also equal to 5 seconds from Q to P when the string becomes again taut. So total time taken is 0.4 plus 0.4. So that is equal to 0.8 seconds is the total time taken when it is going to be taut again. So this is the complete solution of this problem number 6 of this topic of kinematic. Work power energy.